Okay, I'm taking a look at Unit 9 review with you, and I'm going to go ahead and videotape all of the answers. That way, if you've got any questions, I can help you out. I'm going to also just try and write on the screen so it won't be as neat as my handwriting, but at least then we have access directly to the screen. So number one, it says we have to go and find the value of x. Notice there's no special right triangle, so we are just setting up the equation using Pythagorean's theorem. And just to shorten it up, don't forget, we could go and do 23 squared minus 18 squared. Take a moment, type that in my calculator. I end up with x squared equals 205. And it says I need to put it in radical form. So I'm going to factor out a 5, see if I can do anything else with it. It's just 5 and 41, so I can't. So my final answer is just the square root of 205. So let's go ahead and type that in. Unfortunately, it will let me keep the answer and type in at the same time, but we end up with 205. All right, next question, it wants to figure out what type of triangle this is. If you remember, this is when we're using Pythagorean's theorem to figure out the type. I always put my c squared out in front first, so in this particular case, that would be the 20. We've got 20 squared, and we're comparing that to 11 squared plus 15 squared. So doing the math, I end up with 346 compared to 400 compared to 346. 400 is greater than, so we talked about the only way that can happen is for that right angle to get larger, which means in turn this triangle would be obtuse. All right, I'm going to go ahead and type in my answer. We said it was obtuse. Okay, now in this particular case, we are shown that we've got a special right triangle. You should have your formula sheet. If you don't, I can quickly draw it. This is x, this is x, this is x radical 2. So if you notice in our case, x's are, this piece right here is equal to 12. So to get from the leg to the hypotenuse, all I need to do is multiply by radical 2. Reading the directions, it says to leave it in radical form, so our final answer is 12 radical 2. Now in this case, we're going from the hypotenuse back to one of the legs. So to get from the leg to the hypotenuse, we multiply by radical 2. In this case, we're going to divide. Now, some of you remember the shortcut, 22 divided by 2 is 11, and then we put that radical beside. If you don't remember, which many of you have not, we can go ahead and multiply by radical 2 over 2. That gives us 22 radical 2 over 2, which eventually gives us the same answer of 11 radical 2. Okay, this one is pretty much the same thing. We're going from the hypotenuse back, so we're going to take 6, we're going to divide it by radical 2. If you're quickly using the shortcut, 6 divided by 2 is 3. Put that radical beside. If you're not and you're rationalizing, we've got 6 radical 2 over 2, which again will be the same thing of 3 radical 2. This one says we have a square plate, and it tells us the side length is 40. So that means we've got 40 here and 40 here, and they're saying a chopstick can fit along the diagonal. Two ways we could do this. We could go and use Pythagorean's theorem. If you did that, you would have x squared equals 40 squared plus 40 squared. Or we can recognize it's a 45, 45, 90 triangle, and we know that because it's a square with two sides that are the same. And to get from the leg to the hypotenuse, we simply multiply by radical 2. Notice in the directions here, it says we get to put it in in decimal form. Typing that in, I end up with x is equal to 56.6 to the nearest tenth. Maybe actually, I did this one backwards. We were given the diagonal was 40, and we have to get back to one of the sides. So we're taking 40 divided by radical 2, and I can go ahead and type that in my calculator, and we end up with 28.3. Let's go back and fix. All right, now we've got a 30, 60, 90. Again, if you look at your formula sheet, I'll go ahead and draw that picture out. It is labeled, this is S, this is 2S, this is S radical 3. And you've got your 30-degree angle up there. So to start with, we have the hypotenuse, which would be equal to 12S, which means our small leg over here is divided by 2. So 12 divided by 2 is equal to 6. And then to get to the long leg, we simply take 6 and we multiply by radical 3. So our small leg is 6, and our long leg is 6 radical 3. Another one, this one's pretty much the same. Again, to get from 4 back to the small leg, we're going to divide it by 2. So 4 divided by 2 is equal to 2. And then we're taking 2, we're multiplying it by radical 3 to get to the long leg. So again, the short leg was divided by 2, the long leg was multiplied by radical 3. Number 9, they want us to find the area of the parallelogram. Again, if you go look at your formula sheet, the area of the parallelogram is area is equal to base times height. In this particular case, our base is 19 and our height is 9. And remember, the height is how tall the parallelogram. The 14 is just the length of one of the sides, so that's extra information that we don't need. When I multiply those together, I get an area of 171. Next one, we have to find the area of the triangle. So a couple different ways we could do this. We can use our formula 1/2 base times height. What you would want to do in this particular case is recognize the best base to use is either the 30 or the 31.5. And I say that because the other piece is the height. Remember, when we draw on that height, it ends up being perpendicular. We end up with 472.5. Now, our other option that we added on, and if you look at your formula sheet, is the formula that is 1/2 BC times the sine of A. Let's see, it didn't come out very well. B and C are any two sides, so in this particular case, I'm using the 30 and I'm using the 31.5. And then I've got the sine of an angle, and here's the key. The angle has to be in between those two sides. So I couldn't have used the 43.5 and the 30 over the 43.5 and the 31.5 because I don't know their angles. But I at least know I've got that 90-degree angle. And again, if you go and type that in, we should come up with the same answer, 472.5. This one says the area of the shaded triangle. Our formula is 1/2 base times height. In this particular case, we can see our blue shaded triangle has a base of 2 and it has a height of 6. Again, the height is how tall it is directly down and perpendicular. So multiplying those two together, I end up with an area of just 6. Okay, I've been told the area of a parallelogram. I'm going to write out that formula. We've got A equals base times height. We know our area in this case is 30. We don't know the base, but we do know the height is 5. And we saw one of these on our last quiz. We are solving for the base. So in this particular case, your base is equal to 30 divided by 5, which ends up being 6. This one says we're looking for the area of a parallelogram. So again, starting with our formula, we have area equals base times height. We need to go find the length of the base. We're going B, D, J, K. So the length of the base would be from B to D, which is 4 units. And our height is how tall that parallelogram is. So I'm starting at the top, and I'm dropping it straight down. Its height happens to be 4 as well. So we have a base of 4 and a height of 4. Multiplying those two together, we end up with an area of 16. The next one is a composite figure. Lots of different ways that you can draw it. The best way I see to break it down is possibly right here. So we've got a rectangle plus a triangle. So again, I'm going to write out rectangle plus triangle. So that means we have base times height plus 1/2 base times height. So the base and height of that rectangle, I see a base of 70 and I see a height of 90. When I multiply those together, I get 6,300. Then on the second one, I see a base. We're going to have to do a little bit of subtraction. The whole base is 250, but I have to subtract off that 170. So that means we have 180, and this isn't showing up very well. And then my total height is 90, but again, I have to subtract the 40, so that means the height of that triangle is 50. And I get 4,500. And again, not doing a very good job drawing on the screen. Anyway, eventually I add those together. I'm coming up with 1,800. Oh, I lost a 0 in there. Let's try 10,800. All right, the next one says it's an area of a trapezoid, so I am going to use the formula for that, which is 1/2 the height times the sum of the bases. So we've got we've got 1/2, and I think I'm going to have to do it on the next video. I'm running out of time and I'm not doing a good job on the screen. So I'll stop here and pick it back up on the last 7 questions.